All right, this video we are working on page 48 in your notebook, and our objective is going to be to factor a quadratic trinomial. And so just as a real quick review, our quadratic trinomial means that our highest degree is to the second power and that we have 1, 2, 3 terms. Now, we have been working on this, but our problems before our a, or what we call our leading coefficient, had equaled 1. And today we're going to focus on when that leading coefficient does not equal 1. Now, keep in mind that as we're going through all of our different types of factoring, that we're still working on that the first thing that we always look for is if there is a greatest common factor. And then after that, the number of terms tell us what we're looking for and how we're going to complete the problem. If we have 2 terms, then you can see that we look for what we call the difference of 2 perfect squares. And the pattern that we look for is a perfect square minus a perfect square. If we have 3 terms, we use that idea of doing the reverse of the box method or the reverse of FOIL to be able to figure out what our factors are. And you're going to see that our process for when a equals 1 and when a doesn't equal 1 is very similar. If we were going to look at 4 terms, then we would take those 4 terms and use grouping. So we would take the 4 terms, group them into 2 groups, and take the greatest common factor out of each group. All right, so let's look at some examples where we have a quadratic trinomial where a doesn't equal 1. Once again, we're using the examples on page 48. All right, so our first problem is 2x squared plus 3x plus 1. Okay, and I always look and say, well, the first thing I look for is there a greatest common factor? And that greatest common factor can either be with the numbers, with the coefficients, or it could be with the variables. So if I look between a 2, 3, and a 1, GCF is 1, so that's not helpful. If I look x squared, x, no x, there is not a greatest common factor that is a variable. So then I'm going to look at this and say, well, how many terms are there? There are 3 terms. I'm going to draw my box and work on this problem from that approach. So let me draw this. Now, this is one where we have a does not equal 1. You definitely want to either be working in pencil or be ready to draw multiple boxes because we might have to do some little bit of trial and error to get to the correct answer. Okay, so I'm going to look at this first term here, and this is 2x squared. Well, 2x squared, I know that the x squared can only be x times x, and 2 only has one pair of factors, 1x and 2x. So I'm going to leave one of these as 1x and make one of these 2x. Okay, so I have the factors of that there. Now I'm going to take and I'm going to look at that constant term, what we call the c term when we're looking at this in ax squared plus bx plus c. So if we look at that, that is a 1. Now, if this was a number that had multiple sets of factors, we would have to go off to the side here and figure out all of those factors. But we don't have to do that this time. A 1 can only be a 1 times a 1. Now, it could be a -1 times a -1, but I will have to work that out with my middle term to see if that comes out correctly. And so I'm going to take, and if I know that this c term is positive, then I know one of 2 things is true. I know that either when I go to break my binomial factors, that they are going to be two positives or they're going to be two negatives. Now, how I can determine what they're going to be is by looking at this constant term, or by this middle term. If this middle term is positive, then I know that both of my parentheses are going to have to be positives. That's going to be helpful because I know that what's going to happen is that I'm going to put a +1 here and a +1 here. And then I'm going to try. Let's see if it works. Well, if I have 1x times 1, then that is going to give me 1x. If I have 1 times 2x, that's going to give me a positive 2x. So now let's see if we have the correct terms. Well, this is a 2x squared. Yes, that was in the problem. We have a 2x and a 1x, which is 3x. And then we have a positive 1. And so then that tells me that I have indeed found the two factors, the two correct factors. One of them is right here. And so I'm going to write that as x plus 1. And then one of them are here. And I'm going to write that as 2x plus 1. And keep in mind that we talked about that we could also have this written with this first, the 2x plus 1, and then this x plus 1. These answers are the same. You don't need to write them out both ways. All right, so let's look at another example. Number 2 is 2y squared plus 5y plus 2. Okay, so I start by asking myself, do I have a GCF? And so I look at 2, 5, and 2. My GCF is 1. That doesn't really help me with the factoring process. If I look at y squared, y, and no y, there's not a variable that's in common either. So for this problem, there's no GCF. I then look at the number of terms, 1, 2, 3, and now I have 3 terms. And so I know I'm going to draw my box and use that to help me think through the problem. And so I'm going to take and say that this is, here's my box. Now, if I'm thinking of this as ax squared plus bx plus c, okay? There are a couple of givens that I automatically know when I go into this, okay? First, since this number here is prime, the 2y squared, I know that that must be 2y times y. Now, when I wrote that down there was no reason why I wrote the 2y here and the y up there, okay? I could have written the y here and the 2y here. That doesn't really matter. I'm placing those first, kind of like anchoring them down, and then I'm going to place my other numbers around them. Okay? Now here is something that I know. If I look here at my constant term, my c is positive. And we talked about with the last problem that if c is positive, then we get a positive product by multiplying together either two positives or two negatives. And if I look at my middle term here, the middle term is positive, and so that tells me that before I even begin, I know that my factors are going to have two plus signs in them. It's just always a good way to check your multiplication, check your signs there. Okay? Now, let's look at what we have here with our 2. Our 2 goes here. If we had factors of 2, we would go here and write them out and use another process we'll talk about in a little bit to see where which factor is going to go where. But I know it can only be 1 times 2. So I'm going to take and I'm going to place the 2 here and the 1 here. And I know that we've talked about that they're both going to be positives, so I'm going to put a +2 and a +1. And I'm going to see if this works. So I'm going to take and say that when I multiply a y times a +2, that's a +2y. And if I multiply a 1 times a 2, that is a +2y. And then I'm going to check. So this is 2y squared, that's correct. This is 2y plus 2y, which is 4y, and I need a 5y. So something is wrong here. And so this process has a little bit of trial and error to it. So when I put in the 2y squared and I wrote the y and the 2y, I said that I've anchored those in. I'm going to keep them there. But what I can change is when I put the 2 here and the 1 here, I could have very well reversed that. And I could have taken and put the 2 here and the 1 here. Now I'll also need to erase this out because I'm going to try this again, trial and error, with this particular problem. And they would still both be pluses, so let me see what happens this time. If I take a 2 times a 2y, that's 4y. And if I take a y times 1, that is 1y. And now if I go to check, well, there's my 2y squared, it's still there. But now when I go to add this together, the 4y and the 1y, that combines to 5y. Here's my 2, here's my 2. So now I know I have the correct combinations. Here is one factor, y plus 2, and here's the other factor, 2y plus 1. Keep in mind, we could have this written like this also. Okay, this is definitely an or. We don't need to write them both out. All right, so let's look at example 3. So example 3, we start up here, is there a greatest common factor? So if I look at 3, 1, 4, not a greatest common factor, that's a constant. X squared, x, no x, there's not an x that's in common. And so now we're going to take and start to look at how many terms do we have? Well, we have 3 terms, and so that's going to be the box method. Okay, so I'm going to start with this 3x squared. 3x squared, 3 is a prime number, it's only 1 times 3, so this has to be a 3x times x. And remember that I'm going to put those in there and anchor those in there. However you've chosen to put the x or the 3x, whichever way. And then I'm going to trial and error, adjust and modify the rest of the problem. Okay. Now, let's take a look at what we can notice here. If we look at this ax squared plus bx plus c, this time we notice that c is negative. So if you think about multiplying 2 things together and the product being a negative, the only way that we can do that is by multiplying 1 positive and 1 negative. So that tells me a little bit about how my factors, what the signs in my factors are going to be. Okay, so I'm now going to go to this -4. And if I think about -4, I know that the factors are 1 and 4 and 2 times 2. Now, since we know that C is negative, and I have to have one positive and one negative, then the factors of 4 could be negative 1 times 4, or 1 times negative 4, or a negative 2 times a positive 2. Those are all the possible combinations that we could have. Okay? Now, if I go to look at this middle term here, what we're trying to do is we're trying to get this to be a middle term of negative x. Now, when a equaled 1, all we would do is take and figure out the sum of these, and it would tell us which set is the correct set. When our a doesn't equal 1, I have to do a little bit more trial and error. So I'm going to start with 1, and if it doesn't work, I'm going to move to another one. So I'm going to start with just trying this one, the 1 times a negative 4. And so I'm going to put the 1 here and the negative 4 here. Now I've just placed those, and I might have to monitor and adjust those, okay? So let's see what would happen. I would have a 3 times a negative 4, that's a negative 12x. I'd have a 1 times an x, that's a positive 1x. And so when I would look at my answer here, here's my 3x squared. What happens here when I go to combine these, a negative 12 and a positive 1, gives me a negative 11, and I want a negative 1. So that doesn't work. Now, there's a couple of things that I can change here. I can go on to the next set of factors, or what I can do is take and move where these numbers are. So we had a 1 here and a negative 4 here. What about if I put the negative 4 here and the 1 here? How does that change the boxes? So let's look and see. If we have a negative 4 times x, negative 4x. If we have a 3 times 1, 3x. And so let's check. Once again, there's our 3x squared. If we combine here, this is going to give us a negative 1x, which is what we want. And there's our negative 4. Okay, now if that would not have worked, if this right here would not have added up to a negative 1, I would have had to go to my next set of factors. And I would have to try them in both locations to see if it worked. And if they didn't work, I'd have to go to my next set of factors. So these problems definitely have a little bit more problem solving that you have to endure through the problem. And you'll be able sometimes to get the right combination very quickly. Sometimes it's going to take you a little bit to get through there to get the correct combination. So you are going to have to stick with it and try several things to be able to get to the answer. So don't get frustrated with that. So here's this, 3x minus 4 and x plus 1. And you could see that we had said that c was negative, and so when we looked at our answer, one of them should be positive, one of them should be negative, and that's what we have. One is positive and one is negative, okay? Now keep in mind that you can also have your answer written as x plus 1 times 3x minus 4. Those are equivalent. What we cannot have is 3x plus 4 and x minus 1. Those would produce a different middle term and would not be the correct answer. Okay, so the order of these over here doesn't matter, but the sign and the number, it does matter. The 3x must be with the minus 4, the x must be with the plus 1. All right, we've got one last example on page 48. Starting at the top, think about it. Does it have a greatest common factor? So we look at 5, negative 3, and negative 2. There's no GCF. And so we're going to look then and say, well, we have 1, 2, 3 terms. So I'm going to take and draw the box. I'm going to take this 5y squared, 5y squared. 5 is a prime number, so it can only be 5y times y. I'm going to put those down and anchor those in. Now, once again, I could have put the y here and the 5y there. That would be just how I start the problem, and I would adjust everything around it. If I look here, I have a -2. Okay. Now, think about what we did on the last problem. What we know is that if c, that constant term, is negative, then what we know is that our factors, one is going to be a sum, one's going to be a difference. Okay. Now, I'm lucky that 2 is only 2 times 1. So this is either a -2 times a +1 or a 1 times a -2. So those are the combos that I can go with. Excuse me 1 second there. I think I wrote that wrong. I could either have a -2 times 1 or a +2 times a -1. Those are our two choices. Okay. All right, so if I start with, I'm just going to start with 1 and try it. So I'm going to start with this here, and I'm going to put the -2 here and the +1 there. Now, that was just a placement. I might have to adjust it. So now I'm going to take and multiply. -2 times y is -2y. 5y times 1 is +5y. If I go to check myself, the 5y squared is there. When I go to combine like terms here, I have a 5y minus 2y. That's going to give me a +3y. I want a -3y. So here's what happens. When I have the right coefficient, but I have the wrong sign, what it tells me is that these numbers are in the correct place. What I need to change is where the positive is and where the negative is. So therefore, this -2 there, I'm going to take and make it a +2. And this +1y, or +1, I'm going to take and make it a -1. I'm also going to have to erase these out because that's going to change those also. And so now I'm going to take and say that we have 2 times y, that's going to be 2y. And then 5y times a -1 is a -5y. So when I go and check now, I'm going to take and say that here's my y squared. 2y times a -5y is going to give me a -3y. So now my sign and my coefficient are correct. And then there's my -2. That tells me that I now have my correct set of factors. This is going to be 5y plus 2. And this is going to be y minus 1.